Hi, and welcome back to my lessons. In this lesson we're going to be talking about some various array processing templates. First one we're going to look at is a template for searching an array. And so what I've done is I've already provided you with the code for the array. Let's print the array. So now what we want to do is search for an element. So we're going to call that element find. And we're going to create a variable position, and we're going to assign it -1. And the reason we're doing that is that if we find the element we're looking for in the array, we're going to assign it its array index position. By setting position at -1, we're saying that if we don't find the element in the array, then with position holding -1, which is a impossible index position to have, then we clearly did not find the number or the element, whatever it is, in the array. So let's prompt the user to enter a number. Oops, there we go. Find is our variable. We'll use a range for loop. And we're going to say if find equals the number that we're searching for. If find is equal to the number that's pulled out of the range, find is the number we're searching for. If num is pulled out of the range and it equals find, then we want to assign that index position to our position variable, and then we're going to break, so stop the program. We don't need to go any farther. Otherwise we'll just keep looping through, and either we'll find what we're looking for or position will hold -1 still. Okay. So then we can say if position is greater than -1, let's scroll this up a little bit so you can see it better. And then we'll just write a little statement to say we found it. Otherwise, we're just going to do a print line here, sorry. We can just say it's not in the array. Close it off, make sure we have a closing. We do. So we'll save the file. Clear our screen from before. Compile and run. Taking a moment here. Oops. So line 32 has an error, so let's go find it. Again, I like to leave my errors in. Some old C++ habits. Boolean, that else has to be on the same line. Alright, there we go. Try again. Okay, so there's our array. Let's search for 3. It's going to find it twice, but we'll look for the first. That's at position 11. That's good. Let's run it again. This time I don't see, no, just pick a number. I don't see 77. Oh, 77 is there. Let's try it again. I don't see 10. Okay. So that's our linear search returning an index. You could also write a linear search returning true or false, but we didn't do that. So, the next thing I'm going to do is demonstrate how to make a deep copy. And a deep copy is where you actually copy all the elements of an array, element by element, so that you don't accidentally have an array that shadows another array. So let's erase all of our searching code. And now let's create a new array. Same size as the original array. And again, we're going to use a range for loop since we're processing every element, and we're simply copying the old elements from the old array into the new array. And we can do a format print line numbers copy. So that our first array is the old one and our second array is the new one. Let's clear the screen, compile it and run it, and there they are. Our last example, we're going to demonstrate how to insert an element into an array. It's a little bit more complex because we have to shift. So I'll demonstrate that in just a moment. We're not going to be doing a bunch of random number generation this time, so I'm going to get rid of those. Let's clear out the old code. Actually, we can leave a couple in here. Now we're going to just delete everything down from here. We'll start over again. Okay, so I'm creating the new array from the list. Notice I'm leaving out the value 74. That's the value we're going to enter. Okay. So before I get into that, well, let's print this out. What has to happen here? For 74 to be inserted, what we're going to have to do is we're going to have to move 90 over 1, 89 over, 80 over, 78 over, 77 over, 76 over, and 75 over to make room. Notice we only have 10 elements in the array, but our size is 20, so we have some extra space. So we can do the shift. So let's demonstrate how that's going to work. So we're going to create a new grade variable, and it's 74. Then we have to figure out where to start from. So what we're going to do is we're going to write a loop. And if we get to a point where the grade that's in the array is greater than the number we're trying to put in, the new grade, then we're going to stop, and that will be our insertion point. Then we write another loop that starts at the last position of the current array, moving backwards. So we're starting at the last position and moving backwards. Move that position over 1. So move the current grade over 1 to the right. So I plus 1 gets grade sub I, or grade sub I plus 1 gets grade sub I. That shifts everything over to make room. Then where our position is, gets the new grade, and we should be done. So let's take a look. the screen, compile and run. Okay, so there's 71, 72, 73, 75, 71, 72, 73, 74, 75, 76, and so on. So there's a good example of how you insert into an array. And understand that it's a very inefficient process because you have to do the shifting before you can insert. And as I mentioned in the written lesson, when you have a data structure or a data set that requires a lot of insertions and deletions, then you should probably pick something other than array, such as a linked list, which is beyond the scope of what we can talk about in this course, but you'll be looking for it, or you'll be able to see that in my advanced course on Go programming. So that wraps up this lesson on our various array processing templates. Thanks, and I'll see you in the next lesson.